let's go live. Okay. That's interesting. Anyway. Hello, folks. Welcome back to a very special session of MicroCinema 4K. At least that's what this is called for those of you on YouTube. But we are doing something new tonight. Very excited about this. We are theoretically, at least according to OBS says it over there, we are live right now on Twitch and YouTube. And that's pretty cool. Yeah, let me just kind of break this down for you real quick. I talked about it a little bit last week. But basically, Twitch is now okay with you like simulcasting 2 streams. Before they didn't want it on competitor services, and but they recently changed that, and so I decided, you know what, like I know I have a lot of folks over on Twitch who they just maybe aren't as plugged into YouTube. Maybe they don't know that I have a YouTube channel or something like that. So now I'm affording us 2 ways to watch some really great microscopy. Let's see, let me get this back up. There we go. Excellent. Welcome back, Shadow. Good to see you. And yeah, the way this is going to work, at least theoretically, that's how it's set up now anyway, is that for MicroCinema 4K, which is the YouTube broadcast in 4K, we will do kind of what we have been doing, which is I start off, I'm on screen, I say hello, and then I go away, and it's more of a clean feed, and of course it's higher quality. It's 4K. It's a much higher bit rate. But then on the Twitch, when I go away on the YouTube, I'll remain on the Twitch. The Twitch will be more of a twitchy broadcast. I have had some feedback where people say, hey, I would like to actually see you while I'm watching, which is perfectly understandable. So now there's 2 ways to watch. It's up to you which one you want to watch on, and we will kind of over time kind of work on this and see what we can do. But at least so far, we look like we're not having too many issues on the encoding side of things. It took me a little bit today to iron out the like kind of slowly dial up the encoder settings until it was like stable, but like the maximum quality for both. Yeah, I'm stoked. Looking forward to seeing some of my Twitch faithful again. And yeah, so yeah, anyway, oh yeah, and then just one more thing, right, is if you're talking on, this is more for the Twitch people that don't know, on the YouTube feed, you're going to be about like 20 to 30 seconds delayed versus the Twitch feed and the price you pay for higher quality. So Twitch is a little bit more engagement heavy. And Diatoms Attack is in here. Polarized Sir McLean, welcome in. And yeah, I think it's a great idea. 2 eyes, 2 streams. Double the subs, all that kind of stuff. So, but yeah. Anyway, let's talk about the samples. Today I went out to the kind of the South San Francisco Bay shore. I went to 2 different parks, and I basically collected from one area where it's kind of more of like a natural bay, and the tide comes in and leaves these like kind of puddles around, and this sample here is actually from one of my this is like one of my go-to puddles. I always get good stuff here. This is like pretty salty stuff. The substrate is like black and sulfurous and just icky smelling. And then I went to a salt marsh and took just a sample from walking on the boardwalk. Actually, if you see the thumbnail for the YouTube, that's kind of where I was. Yeah, so the cam is intentional for on YouTube. It should be larger at the beginning, and then what will happen is I will go away. My face will no longer be there after the intro, and then we will be gone. Oh, hey, all right. Look at this. We get to do a classic. Let's see if I can remember how to ban people. Let's see. Ban. There we go. Banned. Excellent. Cool. Oh my gosh. We got our first ban in. This is great. Okay, well, with that, let's get the show on the road here. Okay. Yeah, here we go. Let's see. Doing good. Just checking. I might be checking my my life signs, my streaming life signs a little more often than usual, just because we're trying something new tonight. Things could go wrong. Welcome in Zenith on YouTube. And yeah, so here, this is a deep well slide that I prepared earlier, and yeah, like I said, this has come from kind of one of the puddles that I've found. It's always there, and it kind of, I think it never really like fully dries out, and so it's been like a standby place for me, right? I just always find something interesting. Hey, Sydney, welcome in. Welcome in, Stacy. Marcos. Hey, everybody. Everybody's filing in. And yeah. So we got here in the middle, this little cutie pie is of course a polychaete larva. And since we've got since we got a lovely deep well slide here, we can see how wonderfully agile and really enthusiastic. It's got a lot of personality. The polychaete larva always have lots of personality. Really fun to watch zooming around. Oh yeah, and then just one more thing is, if you are watching it on YouTube, just do remember to actually make sure that you're streaming in the quality is set to 4K. I've had people watch before and they've been on like 480p or something. I'm like, oh no, that is not acceptable for what we're trying to do here. And this is a cool find, because this is something I didn't know could happen, but this is pretty salty stuff here. This is probably saltier than normal. This is kind of an area where you'll get like, the puddles the tide will go out and the puddles will evaporate a little bit and it'll be very saline. But we have Basilaria in this sample, which is neat. I didn't know that Basilaria could be a marine species as well. But yeah. And then we got something here too. This looks like, I don't know if this is Melisira or not. This is with the 10x. We can come back a little later. We'll do some more zooming in on that. Yeah, so we'll use dark field here for a while and check out these critters. So yeah, this sample. Oh yeah, we got this big worm here. It's like maybe a planarian or something, and then we got this big annelid here. That's just looking real cool. You can see the blood pumping around in there. Got a lot of good worms in this one. Yeah, and then we have these. I remember we've had these on before. These super cute little orange worms, and they really are like that orange. It's pretty remarkable. You can just barely see them when you're looking in the jar, but they have this like really dramatic orange color to them. And so it makes you wonder what they're feeding on. Maybe a scenario where they're getting their color from something they eat. And yeah, and then we just have a lot of like fun little zooplankton around, these little Naupliuses or Cyclops and whatnot. Yeah, this puddle is just always so vibrant with life, and I found different stuff kind of every time I go there. This time I didn't find quite as many ciliates as I usually do, but it is also it's you know, it's winter time now, so that might be changing what we see. So let's see, what do we want to do here? Let's go. I'm gonna pull out my my low mag turret here, and I'm gonna swap in my high mag turret. Oh yeah. Heavy. Okay. Oh, that's interesting how that changed. Let's see, that is that. Okay, I gotta do a little this way. Kind of weird. I'm getting like a. Oh, there we go. Excellent. Yeah, Zenith asks if I know the orange worm's identity. I do not. But maybe those are a good candidate for just kind of, you know, doing a little Google search or something. You know, orange marine worm or something like that. Orange marine flatworm. I think they're definitely flatworms. Maybe that would get us something. And there's our little polychaete friend again. So this is a polychaete larva, and a polychaete worms can turn into like, or the larva can turn into all sorts of different kinds of worms. And the larvae themselves have like all sorts of different life stages, and it's pretty interesting. Okay, yeah, I think we're doing okay. Please do let me know in the comments if the video starts to go bad or something like that. I did test this earlier, but the performance of the encoding kind of depends on how difficult it is to encode the video. So when there's a lot of activity or fast moving stuff, things could get hairy. So if they do, we'll figure it out. Hey, Bernie Mac, are you the real Bernie Mac? That'd be quite surprising for numerous reasons. Yeah, the spider-looking thing zipping around the place. Maybe like this little guy here. So this is some kind of crustacean larva. Yeah, there's a bunch of them. I know we have some. I saw some. I don't know if I have them in this sample or not. But we have some that are, or like one that I commonly see is barnacle larvae. Barnacles, like, you know, are pretty weird looking critters. But they start life out as kind of these pretty normal looking crustacean kind of things. And we have a cool, this is actually an interesting one. I don't know if we've had this species before. This guy here is a rotifer. Well, this girl here is a rotifer. A very interesting body type, kind of almost like a fingernail or something, kind of beveled. Oh, okay, that's cool that you gave it to you though. And then I don't even know what these little things that are moving all over the place are. Maybe we'll get one that's like chilling out sometime and we can kind of give it a better look. All right, thanks Zenith for offering to do some investigation. Yeah, this rotifer is really cool. I like it. I guess that's, oh yeah, this is the same species, but this one's got a this one's got an egg in tow. So it looks like kind of there's like the beveled shape and then the egg kind of nestles in there. That's clever. And here's that kind of big planarian or something here. Chilling. See if we can find those. Yeah. Wow. They like turn down the exposure a little bit. They're just so bright. Yeah, these things are just super cute. Look at those little eyes, like wonderful little worms. Okay, yeah, so let's see, there's that. Let's see, I'm just gonna work on my desktop here a little bit. Okay, excellent. All right. Yeah, so right now we're using a 10x objective. This would be equivalent to something like a 100 or a typical view when you're using a 10x eyepiece. You could call it 100x, although I don't like to use that kind of terminology for numerous reasons. Still working, by the way, on the automatic magnification dealio. Oh, this is a little tiny worm here. Little baby worm. It's absolutely moving. Not much bigger than a lot of single-celled organisms, but probably moves in a very like unique way to the point where you can tell it's a worm. Those two little eyes too. Pretty much a dead giveaway. And there's our little polychaete. So let's go ahead. We'll change to DIC. So give me a sec. I gotta swap in my condenser. There. Boom. Pop that bad boy in. Take this off. Pop that in. And move this up. This centered. Oops. There we go. Excellent. Down 125, which is usually where we are here. Yeah, this has been a while since I've done the open that up. It's been a while since I've done the deep well slides with DIC, so it might look a little weirder. Oh my gosh. Oh yeah, sorry Anthony. You will be subject to random flashes of blinding white screens sometimes. I apologize for that. Yeah, is there any cognitive or chemical reason they move the way they do? You know, the worms have some level of, you know, they've got like neurons, I guess, or you know, something very rudimentary in them. You know, the single-celled stuff is you know, very, very like rudimentary. I tend to kind of imagine single-celled organisms as basically like these complex little machines. And the worms aren't too much different, but you know, at least they have like specialized cells that are all working together. This is what is this? What is this thing? The heck? Is it like just a rotifer that's... Yeah, okay, that's what that is. That's one of those rotifers. It's like anchored to the bottom, it looks like. 20x here. That, boom, and then boom, bring that down. Yeah. So like, I think that's like mouth kind of pointing down, and as I come up, that's the rear end. You can actually see the egg kind of in tow there. Like the egg is pretty new. I don't see any, you know, well-developed rotifer in there or anything like that. Hey, here's one of our little friends here. Been eating some green stuff. Maybe eating these little algae that are swimming around here. There it goes. These things are cool. It's too bad I don't have my fluorescence set up going. I bet these algae would probably fluoresce all sorts of ways. It's been my experience anyway when looking at marine samples. Like, you get a lot of like little flagellated algae that glow all sorts of different colors. Let's go back to the 10x objective. And boom, bring that down. And yeah, let's just keep looking around. All I can eat. And there goes one of these rotifers. This is that big annelid worm. You're old. I wonder what this thing eats. And sometimes you can see recently ingested stuff. Oh, look at this. Oh, whoa. Check that out. Guys, oh my gosh. Hey. I did not give you permission to leave. You guys see there was a little ciliate that was kind of lounging, swimming around on the worm. I'm not sure if it's still around. That was cool. I always like to see stuff like that. Here you can see, so now we're kind of we're viewing the top of the worm. There's its mouth, that like line, that vertical line going down there. That is the mouth of the worm. Oop, there we go. You got to see it open up a little bit. They do look a lot like the worms in SpongeBob. You can see they have these kind of like claws, these bristles they use to move around, kind of grab onto stuff. And then just pay attention to like these pink tubes, and you'll see that they kind of pump full and then clear out. I don't know if blood is the right word, but essentially it's blood. And there's the worm butt. Pretty normal butt, pretty standard worm butt there. No crazy anal gills or anything like that. Okay, good. Oh, look at this. We can kind of see here. We can see some diatoms. That's actually looks like Nichia, maybe. Nichia or Fragillaria. And frustules inside of the worm there. I think this is this brown stuff here. That's a good worm turd there. That's under development. Always fun. You know, the nice thing about like, especially with DIC here, is just like you get really great like cross sectioning when you focus down through stuff. So it's like almost like giving this thing an MRI or something, you know. Munch on here. Munch on some detritus here, perhaps. Seems like a detritus muncher more than anything else. Oh. Hey, the other slide. Welcome in. Yeah, again, for anyone just now joining, we are, for the first time ever, we are live on Twitch and YouTube at the same time. I guess, wait, is it the first time ever? Did I do this one time back in the day? Yeah, it did. But anyway, this is actually, it's kind of fun. This is, you know, you were here from the very start of this channel. I started off doing dual streaming on Reddit and Twitch. So this is like having two OBS instances up and like juggling both of them, kind of taking me back. Yeah, so I generally stream for I don't know, 2 to 3 hours. It really just kind of depends. Trying to figure out if this so this is like a cyanobacteria hole. Is it still alive? Let's see. That's that. I might be able to get the so let's try do something like this. Try to get the 40x on this. Maybe this is like a sulfur fixing bacteria here, which would actually make a very large amount of sense. I don't know if it's like Vegetoa. It looks like maybe it's Vegetoa. I don't know, but I believe the little granules in this thing are sulfur granules. And the thing is it's moving. No touchy. It's moving, so I don't think it's just dead. It looks like a dead Oscillatoria, which is what I thought it was initially. Let's see, I think I can do this. Okay, I gotta be careful. This is good. This is better this way. Yeah. So this is, anytime you like get some muck and it smells like sulfury, rotten eggs, you should expect to see some sulfur bacteria in there. And that's what I think we have here. And this stuff was, let's see, if I go back to maybe like the 4x here. Let's go this way. Sorry, let's pop this on and then take this out and then close this down. That's pretty decent. Why does that look weirder than usual? I'm getting as much as I should, but figure that out later. Yeah, so if I go like over here, yeah, so all this like black muck here, as I was like messing around with it in the petri dish, I saw that a lot of these like translucent Oscillatoria strands were like binding this stuff together. Yeah, so when I was messing around with it, I thought it was just like, because you can see here, this is like a normal Oscillatoria or something. This is like a normal cyano with chlorophyll. But yeah, I guess this stuff is actually alive, which is neat. Oh yeah, and then we have let's see here, so I'll go here and pop that in, boom, take that out, boom, here. This is a marine rotifer here. There we go. Pop that in, there we go. Let me see. And actually, I don't know why it's kind of looks like it's pinned. I think it should have room. Yeah, this is just an interesting rotifer species. I don't know what the species is offhand, but it's one that I've only seen in marine samples before. And actually something you can see here is if we look down into this egg, we can see a little red eye, and then you can see the cilia kind of fluttering away. So this egg seems to be pretty far along in development, and could hatch at some point in time. Oh, here's our orange worm. It's got the two little like kind of feeler protrusions there. Oh my gosh. Oh my gosh, it's just so orange. Ridiculous. These things. What the heck are these things? I think they're little ciliates. Like little halteria-ish ciliates or something. they just move too fast. I'm pretty sure I see cilia. The only other thing it could be is like really tiny little crustaceans or something. But that'd be hard to say. And yeah, this is, we are in differential interference contrast right now. We got a little dinoflagellate there. That's the kind of thing I'd be like, okay, maybe this worm is gonna snap those up. But hard to say without actually watching this thing make a move. There's that little, this is a really interesting flatworm here with just the very long snout. Very fast too. Hello. Oh, yeah. Yeah, someone in the YouTube chat is mentioning my Aquafina water bottle label trick, which can get similar results to this. But this is actually differential interference contrast, so it's a much more sophisticated technique that uses prisms and polarizers and all sorts of good stuff. The main thing with DIC is that it works at basically like kind of any magnification scale, which doesn't really not really possible with my kind of Reinbergish oblique techniques. But yeah, this is just a 10x objective right now, and so those kind of oblique techniques will work just fine. Yeah, and for DIC, I tend to, this is a deliberate kind of creative choice, if you look through the eyepieces, the background of DIC, and when you have it really set up correctly, is gray. It's just a flat gray. I deliberately kind of tweak the video settings to give more blue background, just because I think it's more pleasant to look at than the gray. I do have a clip on my YouTube where it's a clip of a rotifer. I forget what that one's called. But that one, you can see the background is gray, and that's kind of more representative of like what DIC normally looks like. Yeah, and then the gradient here, the reason why it's not just kind of a flat color in the background is because I'm actually using the wrong I'm using the wrong objective for DIC here at 10x. I can show that maybe. is I have the right objective on my low mag turret here. Go there. Yeah. So here, yeah, and then let's see, let's try this. Boom. Enter that. Bring this up. There we go. So this is kind of a more typical, correct, quote unquote, implementation of DIC, where you can kind of see that the gradient is kind of centered here, and I'm actually capturing a pretty wide field of view right now, more wide than would normally be intended using this microscope. So you can kind of see this is what it would be. It's more even. But the reason that I don't use this is because it's a achromatic objective, and so you can see kind of green and purple fringing when I go out of focus. And then also the resolution isn't as high as my apochromats. Now, more modern microscopes than the Olympus BH2 here, they have DIC systems which were made for apochromats. So yeah, you can kind of, that's one of the benefits of going to a more modern system than the Olympus. Give it a few apochromat prisms for the Olympus, but yeah. Okay. Excuse me. All right, well, these things. So I made another slide with this, using this sample we can take a look at later. Maybe we'll get a better eye on these little guys. They're moving up and down too much. They can't really block them. But yeah, let's move on to another slide here. And we'll go to this one from the salt marsh. Here. And we'll see what all has been going on in the salt marsh. And you can see, wow, there's like a lot of very small particulates here. This is the 20x. Okay, good, let's check this. Okay. Huh. That's interesting. I wonder if those are little bacteria? Very small, whatever all that is. Well, it's all sinking to the bottom too. I'm kind of, oh no, something. Oh, what do we got here? Ah, it is a rotifer with an egg. Different species than the ones we were looking at before. And you can see we've got this this kind of seaweed here, and this kind of algae that grows on the surface, and got a few strands of that on this slide. This stuff is like really like dense and whatnot. It's not at all like Spirogyra, and it gets really thick. The strands of this get super thick, and so on this slide, like they're actually kind of functioning as the spacers on the between the cover slip and the slide. Hi, Vinny PX, welcome in. I'm good. And right now, this is a rotifer that we're looking at here, which is kind of trapped in this little crook of the seaweed. This is sort of convenient for us, I guess. Rotifers are basically little microscopic multicellular animals. And these ones, this species in particular has these really like stocky feet. The tail is called a foot. These ones have this like really thick prehensile tail, or foot rather, that they use to, well, I don't know what they use it for necessarily. I don't know why they have such a thick specialized tail, but it's neat. And we see a lot of diatoms on the surface of this seaweed here. Let's see, I think I can, let's see, that would be that, and let's see, how far are we? That's the underside of the cover glass right there. So we can come down like this, pop that bad boy there, go here, boom, step that up. Now we're using the 40x objective. So nice nice diatoms over here, little ones. The rotifers can eat a lot of different stuff, but they kind of tend to be usually it's small stuff, so like bacteria, or they'll kind of just like munch on detritus and digest anything that's, you know, digestible. There's lots of different species of rotifers with lots of different kind of like lifestyles. I don't know about that one in particular. I like this nice little diatom here. And we're using the 40x objective right now. Oh, here's a rotifer. See, so it's kind of vibrating its mouth parts against this this seaweed here. So maybe it's trying to eat something or suck some stuff up. I don't think it will eat the diatoms, but I'm not certain. I'm going to switch back to my 20x here. Sorry for the solar flare. Boom. Just pop that down. Pull that back a little bit. And here we'll get a little bit more depth of field, but yeah, you can see they have these pretty wild mouth parts here that stir up the water. So it could be eating just these little tiny tidbits that come in here, you know, all this little stuff. It's hard to say for sure. Take a closer look at. Let's look at these dark little. These are little bacteria. Yeah, I see these lurking around. looking at these, they almost look like little ants or something. Yeah, these are some kind of little spirochete bacteria that I have seen in marine samples. A lot of marine samples have this stuff. It tends to swarm on stuff that creates oxygen, like plant-like organisms. Wow, we got some real nice little colonies here of diatoms. These, I guess these would be epiphytic diatoms growing on the algae here. Let's see, yeah, that should be good. Let's bring this up. Oh goodness. This is back with the 40X again. Unfortunately, having stuff kind of like behind these diatoms makes them harder to look at. But just some nice diatoms. There's a motile one running around. Oh, hey, look at this. We got a little ciliate here, nestled into diatoms. And it seems to just be kind of grazing over the surface of this thing here. Oh, it's got, maybe it's gonna eat that little thing there. Little doodad. You can see it's full of stuff. There's, identify some stuff inside of it, but could be even eating on something smaller than that. Oh, rotifer going through. Okay. A little ciliate there. So we'll zoom back out to like the 10x here. Up. Ooh, that's a curious looking little ciliate there. Kind of hiding away from us right now, though. Oh, look at that tail just whipping around. I wonder what all this is, just like in there. And again, this is from the salt marsh. So this is pretty wickedly salty stuff. Here's another rotifer, another species. Kind of a grubby looking one. Yeah, just inching around. Wow. Well, this is wild. Yeah, I don't think there's if I recall correctly, there wasn't like as much diversity in this sample. It was mainly I remember seeing those rotifers. Yeah, I see we got like these little ciliates over here doing stuff. But yeah, I kind of knew this wasn't going to be as crazy of a sample. Although sometimes, I don't know, sometimes you get surprised. Yeah, this big thing here, so like this algae kind of creates these like air-filled bladders and floats on the surface, and this is like a little piece of that. Are these salt crystals or something? That's interesting. Maybe we'll have to do a little bit of polarized light. Check that thing out. Yeah, I don't exactly recall. Ooh, we got a little crustacean here. A little shrimpy duder. Let's bump that up and let's check this. Okay. What is a Diatoms? Stacy asks. Well, it's a pun. Not a good one, by any means. It's a quickly thought up name, that's for sure. Okay. Yeah, let's go to polarized light. I'm curious to look at this little piece of stuff here. What I'm most curious in are these like little crystals here, which could be like, I mean, it could be salt crystals. Again, this is very highly saline, but you kind of expect the salt crystals to be dissolved. Let's see what we got in polarized light with this thing. Put that up there, and then get our polarizing slider. Come on now, go, boom, drop this in. And then we'll jump over here. Oh yeah, wow. Wow. That lights up. Very. Wow, look at that. That's pretty. Yeah, this is some kind of mineral. I don't know if it's salt. I don't think so. Because let's see. I can't even see it. Let's see. I'm trying to find a little patch of like salt here. Let's see if I can turn this. Yeah. Yeah. So like here's a little streak of salt, kind of off the slide. It's from where the water evaporated. And when I extinguish the polarization, you don't see it anymore. Salt is not very active. Polarized light, this stuff is really active. So this could be some kind of like calcium deposit or something. Wow. That's incredible. Those are pretty. And maybe for those of you that aren't necessarily familiar with polarized light, essentially I'm using 2 polarizers right now on my microscope. Polarizers are basically filters that they only let light through that's vibrating in a certain direction. And so when you cross 2 polarizers, theoretically no light gets through, since the light that gets through the first one won't get through the second one. But certain materials will kind of twist the angle of the polarization, and then they'll show up bright. And that's what we're seeing here. That's so cool. These little crystals. I bet there's like one biologist that like knows exactly what that is. Knows what these little depositions are. That's crazy. This is the 4X right now. Yeah, so we can like go around and turn up my exposure here. See if we can't find some other stuff that's active. You can see there's like little here and there are little things. Rotifers can sometimes have a decent polarization response. But yeah, nothing like this. You can see here I had to turn up the exposure, and like when I go back to this stuff, it's like super overexposed. Which just tells me that it's very strongly polarizing. There's like a ciliate that's been eating some shiny stuff. Yeah. What else going on this? Oh, hey, look at that! Oh, there's a worm that we somehow missed this entire time. And a similar like little flatworm we had on that other one with kind of like the large snout. Glowing a little bit in the polarized light. Whatever it's been eating. Kind of glowing a little bit from inside of it. Oh my gosh. Oh my gosh. Kinsey caught a mouse.
Yeah.
Kitty. Not a real mouse, but a toy mouse, but she had to let me know very loudly about that. Ooh, here's our little crustacean friend. Now, crustacean things often show up very nicely in polarized light, especially the eyes. This is something that's really cool. That I've found, that the eyes just have like this incredible reaction in the polarized light. Hello, Jinut. Junit c'est quoi? Welcome in. Yeah, Kinsey, I think if Kinsey ever met a real mouse, she would just be terrified of it, to be honest. But she's very good at catching the little rabbit fur rattle mice. We can do a little bit of A little bit of fun with wave plate here. Go, just add a little color into this. And you can see these little they're like little bands that are glowing from inside of this crustacean and changing color depending on which way it's pointed. And that is those are mussels, little like tendon kind of things that are connecting this thing. Let's move around. I actually wanted to, I forgot to do polarized light on that last slide. So let's take another look at the slide we were looking at before, but with polarized light. Let's see, we'll pull that off and go to 4x. It's because we had like a lot of fun like little worms and whatnot, rotifers, and this is with the 4x lens right now. Oops. Yeah, this is that big annelid that we were looking at. And then this fiber here is likely some kind of plastic here, because of how bright it's showing up. Plastics tend to be strongly reactive in polarized light. Okay, here's that little planarian. Which, yeah, it doesn't look, it looks very similar to the one we were looking at on the other side. I wanted to see what those little orange worms again. See if we can back them down. Shouldn't be too hard, considering the fact that they're bright orange. But, you know, sometimes. Oh, whoa! Yo! That's unexpected. Wow. Look at that. That's really interesting. This big bright thing here, this is a little dab of Vaseline in the corner of the cover glass. But wow. Look at that. So, yeah, so turn down the exposure, like right, a little bit more. Yeah, wow, look at that. So like the inside, I'm assuming that's the stomach, I guess, right? It's got some kind of like mineral buildup where it's been eating a lot of stuff, but it's like, it's weird how it's really like evenly distributed. Where's that other one at? Here it is. Wow. It's wild because you can't even really like I can turn up the exposure so you can see the worm better, but then the whatever is polarizing inside of that is just blown out. You see the eyes kind of light up a little bit. Wow. Yeah, let's try with the wave plate now. Has the potential to be pretty cool. Wow. Look at that blue spot in there, which suggests that like whatever is right there is like an organ where stuff is oriented differently than the rest of the organism. I imagine if this thing turns, like the red parts will turn blue and that blue part will turn red. Wow. Where's that other one at? It is. Wow, yeah, these are super cool. Whatever these are, they're really neat. Gotta find out what the orange flatworms that really like very salty water. What are they called? They're cool. That's just fire. So pretty. Like watching a lava lamp or something. I see some stuff kind of fluttering in there. I think what else I can do. With this little ciliate. Oh no, that's a little tiny worm that we were watching earlier. Let's see. Can attempt. This polarized dark field here. Or not or yeah, polarized dark field. That is what this. Oh, and there's our little polychaete larva. Let's see. Give me 1 second here. Preparing a filter of sorts. I like that. Blue and gold. Hi, This Bamboo Life. Welcome in. Like you've chatted here before, but I'm pretty sure you haven't been here in a while. Wow. Yeah, let's see. So what does this look like now if I pull this out? Oh yeah, this is like the sky blue background that I can get with polarized light, which is fun. Okay, I'm not supposed to like. It's supposed to be like end of the stream stuff here, where I'm just messing around with polarized light for forever. Wow. Yeah, the red dots are indeed the eye spots of this little worm, little orange worm. Very cool. Oh, you know what we haven't done also? I always make a point. This is, just check it out in good old-fashioned bright field. And I can see kind of, you know, what this little critter, you know, looks like kind of in a normal view under the microscope. Yeah, 10x objective here. Yeah, we can got our annelid worm here. Bright field for often really good at bringing out colors, very natural looking colors. And right here. Okay. Let's go ahead. Well, look at this one. This is from kind of the Bay Shore, and this sample. Oh wow, yeah, there are a lot of diatoms. So there was this area, like I have my normal, like little pond, not even a pond, like my little puddle that I go to a lot at this place. But then kind of farther up the shore, there was this area which sometimes is like flooded over and sometimes it's not. Today when I went, it was pretty flooded over, but there was an area where I could kind of like walk. And it's just a really shallow, really salty, kind of scummy area. And the substrate, the surface of the substrate, hello, here we go, yeah, has this really orange stuff that's kind of build up here. And I remember looking at that and I was like, that looks like diatom orange. And yeah, sure enough, it looks like this stuff is chock full of diatoms. Maybe like antimonies. And then we also have this ciliate, which is a really cool ciliate here. And I forget what this one's called. It's something, I think it's something salina. It is a like hypersaline specialist ciliate. So just really, really loves very salty water. And I found these at a few different places at this park. And we found these before on the MicroCinema 4K stream. It's been maybe a month or two since that stream, but I think I did put the name like in the chapter markers or something on that one. Yeah, everything we're looking at today will be salt water. But let's go ahead, we'll go to DIC, which should crisp up these diatoms pretty significantly. Pull this out. Pop this in. A little slider. There we go. Good. Open that up. And then we gotta figure out, oh yes, let's bring this out. 10x. Wonderful. Wow. Why is that? Why are they showing up so bright? It's unusual. Unusually, like, very bright and crisp here. Which could have something to do with how I've got this set up, but it's pretty normal. Yeah, I gotta like turn my exposure down more than I normally have to. These diatoms are just really shining. Beautiful. Yeah, so we've got some euplodes here, and then we got our little saline ciliate here. Wow, look at all these diatoms. Yeah, this is in an area as well where there's no it's shallow, very shallow, and there's no like aerial cover. So just a great place for a bunch of diatoms to sunbathe. I love these big ciliates here. Let's see. Hold on. Let me see if I can just quickly find the name of that one. Yeah, Fibrea salina. See if I can find like a good link to this thing. Well, anyway, I'll just oops. I'll pop this into the chats here. Wait, why do I have to sign in? Oh my gosh. Sorry, give me 2 seconds here. Boy, vey. Sorry. Oh, there we go. Oh my gosh. Google's making me sign in to interact with my chat on YouTube here. Guess it is me. Ah, Christ.
Solomon, tomorrow is...
Oh boy. Oh, I just messed everything up. Okay, let's just see if I can go back out. Okay. Oh, there we go. Okay. Now it worked. Okay, thank you, Marcos. Marcos came through in the clutch anyway. All right. Show can go on now. If that's the worst thing that happens during this stream, though, we're doing pretty great for... We're doing 2 streams. Oh, it's exciting. This is with the 20x objective here. Yeah, these look like, I think this is just generally one species. It's Entomonies. The Diatoms, that is. That's right. Go to the 40x here. Yeah, so some of these are oriented kind of one way, and some of them the other way. These are all the same species. It's interesting, the chloroplasts are all like kind of really shrunken on them. Some of them have, you see on this one, it's got bacteria on the surface of the frustule. Let's see. Over here. Oh. And there's a little Euplotes, Ciliate. Where'd you go? Hard to keep track of those. They do be scurrying. Okay, let's go back to 10x. Yeah, we'll zoom around a little bit more. Let's see if we can find one of those. Whoa, check that out. Let's see, how's my encoder doing? Okay, encoder's doing okay. Wow, look at this. So this is a nice little isocline that's developing here. There's a Febrea. So this is the edge of the slide. Right here, you can actually see some salt crystallizing on the corner, on the edge rather. And then you can see, so it's either salinity or oxygen, but something is keeping these little flagellates like very specifically at like this distance from the edge. And that's a chunky Febrea there. They're also really big. Well, it's getting close to the edge. The edge is kind of like salted over at this point. Yeah, these little flagellates are neat. I don't know what species these are though. Something monas probably. These are. Oh. Here. Things kind of look like foam fingers or something. But I mean, they're just a very, very like unique shape for a ciliate. There's nothing else that quite looks like that. And I'm not sure if there's actually, like, it could be a monotypic genus. I don't know if there's other Fabreas. I think they might be related to Stentor, but I'm not 100% on that. It's kind of in the textbook where I identified these. They're kind of like placed near Stentor. Nice. What's that one? Oh, it's another Euclides. Whoa, look at these things just vibrating away. Tiny little flagellates. Just wigging out. Some of them anyway. Some of them are dead still. Hey, local. Welcome in. Just... It's so funny. Like every now and then you just come across critters that are, there's no other way to say it than they're just spazzing out. Okay, so yeah, Techie IT asks about okay, taking some sink water, throwing it on the ground or floor, and then collecting a sample. You know, just like you know, stuff that on the floor, you know, mostly I think you would expect to just find some amount of bacteria depending on how clean your floors are. Maybe there's some like dust mites or something. But I think in general, if you did that, you probably wouldn't find a whole lot. That's a cool ciliate there. Looks kind of something like colpoda or something. You know, like to get, you know, a sample that's like this vibrant and alive, you know, I specifically go to places where, you know, I can tell, like you can just tell by like looking at the area that it's like very bioactive. So kind of when you're, you know, dealing with stuff that's you know, not super bioactive, like a lot of times what you have to do is like find some way to increase the concentration of organisms. Because otherwise you'll mostly be looking at a whole lot of nothing. And then as well, like if you just like introduce water to an organism, you might cause it to explode or something. That's something we could do, actually. Kind of an evil little experiment that we could do here is introduce a little bit of fresh water to these marine organisms and see how they respond to that. I've done it before, kind of on accident. Not really, but see, do I have somewhere? I guess I can just pour out a little bit of my drinking water here. So I'm just going to take a teeny tiny drop right here. You can see this is the edge of the slide, and I'm just going to apply a teeny tiny drop of fresh water. And we can see what the effect is like. Oh, great. It's a little bit dumb. Let me undumb something here. I just put a teeny tiny drop on my expensive microscope objective. I'm going to do it on this side actually, so don't have to worry about that. Okay, there it is. And okay, so right over here, I introduced a little fresh water. Yeah, you can see where it's wet out here. The diatoms seem to be handling it okay. Well, it's also possible that it's not getting in too much here. Okay, I'm gonna put a little bit more. Okay, there we go. So here comes, you can see kind of water flowing. Oh, there's a little ciliate there. It's interesting. It's actually, I expected this to be a lot more catastrophic. And, but things seem to be taking it pretty well. They're regulating their osmosis pretty successfully here. Maybe what I'm not seeing those fibrea around, so I'm wondering if they kind of sensed the salinity difference and booked it. There's one looking okay. Yeah, I'm kind of surprised we didn't see these diatoms just like explode. Oscillatoria. Let's see, like there's an oscillatoria, and that's like doing like I did this before, and the oscillatoria would go up like popcorn. But maybe that was just more saline than this. Anyway, good to know. Nice view of euplodies there. Okay. Well, let's go to our last slide. And this is one that I kind of more carefully prepared, and it's from the same sample as the first slide that we looked at tonight. But I specifically got more ciliates, and I got more ciliates in this one, and I kind of prepared it more carefully. So we'll see how that turned out. I'm not seeing any ciliates so far, but hopefully they're still alive somewhere. Saw some stuff that kind of looked like ciliate remains. It actually kind of looks sketchy here. You guys doing okay, I guess? Oh, there's a ciliate. Hey, you see there's these cilia on the bottom here that like have been cast off, which usually only happens when ciliates are under stress. Oh, there's one of those. Yeah, these things. Yeah, these are little ciliates of some kind. You saw these earlier. But now, since I kind of prepared this so that there's a pretty thin layer of water between the cover glasses and the slide, there's less up and down freedom for these critters. Let's see, are they all... Oh, there's one. There's a nice ciliate. The 20X here. Nice. Pretty chunky fellow. And I think inside you can see a macronucleus. So that kind of thing that looks sort of like a large intestine inside of this thing. That's the macronucleus. You can see it's been munching on some golden stuff, maybe some golden algae or something like that. Oh, and here's a little worm. I do remember putting this one on. I was like, oh, that worm's small enough that I can put it on here without squishing it. Little flatworm here. Ooh. Whoa. What's up with this thing? Whoa, wait a second. It looks like a Euplotes because it's got this series, but whoa, look at that. Look how it's jumping. I think those like curled up cilia at the back, or the curled up series, are like it's like flapping them to jump around. This is an interesting little ciliate here. Whoa. Yeah, this is definitely not a normal Euplotes. Definitely a hypotrick. but species that I'm not sure I've seen before. What is this? What are you? Some kind of, maybe like a bacteria colony or something? I'm gonna say those maybe are sulfur granules there. Okay. So let's see, we should have definitely some more ciliates on here. I remember because I put them there. Here's one. I think, let's see. So I'm sure I used that thickness. This one's kind of just barely compressed a little bit, which can be nice. It makes the high magnification a little bit easier. Don't have to do quite as much chasing. So this is with the 40x here. Wow. Not sure on the species for this one. Maybe a Frontonia, a frontonid of some kind. Oh, thanks, Zenith. Zenith says I'm very skilled at following the organisms around. Yeah, I've been doing this for, I guess, like 3 years now. But it's not 3 years now, but it's coming up on 3 years. When I started, I was doing this twice a week. It definitely helps to have, a nice high quality stage. And then just over time, you get a hang of it. It just kind of becomes second nature. So I don't know if you've used a microscope before, but in order to move the stage around, you have kind of the control arm with two knobs on it, one that moves in the X direction, one that moves in the Y direction, and then you have a focus knob as well. So I got like one hand on the focus knob and then one hand on the XY control knob, and then I use 2 fingers. One, I guess I use my index finger for up and down and my middle finger for left and right, and then just kind of over time it's become second nature to the point where I just kind of know how to move them kind of in unison to follow stuff around. Oh, hey, Bubble Shark, welcome in. Long time no see. It's a nice one though. This is good, and this is like, I would say this is a very successful like kind of preparation of this slide. Like I got this ciliate pretty much pinned in the Z direction, so I don't have to do a whole lot of focusing. Here we can see, just focus on like the very top. You can see the cilia eating away. And if we look at what it's been eating, I definitely see some diatoms in there, and maybe some like dinoflagellates too, like this little guy here. Maybe might be something this thing would want to eat. Yeah, just again, this is the first night that I am doing a simultaneous YouTube and Twitch broadcast. My condenser's all way out of alignment here. Oops. Oh no! 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 Oh. Oops. After all that talk about how skilled I am. So I adjusted the condenser. I could tell my condenser was not quite at the right position. And so I adjusted the condenser, but it hit the slide from underneath and pushed it up into my 40x objective, which smushed the ciliate. But now you can see what happens when you smush a ciliate. Okay, it's a single cell organism. It's impossible for it to have feelings. No need to worry, no need to call any authorities or anything like that. You get kind of an interesting look at how it was built here. It's got these kind of these interesting little like sub features. But yeah, the 40x lens that I use is a very fancy lens, and it gets extremely close to the slide. Yeah, easy to bump into the slide if you're not careful. That was a bit of an advanced way to screw up there with the condenser, though. That was really special. You know, sometimes test subjects don't make it. I don't know what else to say. Well, hopefully we didn't smush. Oh boy, we smushed. That's the same one, I think. Oh no, that's a different one. Oh Christ. I might have squished a bunch of ciliates, but maybe there should be some. I think those are on the larger size. There should be some other ciliates on here that were not squished. It's been a while since we had a good old-fashioned murder on the channel. Oh, there's one of those little ciliates that finally slowed down for us. Yeah, definitely like a halteria or something similar to that. Okay. Go back to 10x. And we will look around. See, you know, theoretically, I've got my little glass microspheres on here too. That's one of them there. So like they should provide a little bit of spacing, prevent that kind of thing. That was like right in the middle of the cover glass, so I think it just flexed. I'm curious. So we had, I think we had some Picocercids on here. Oh, hey, this one survived. Okay. Hey, not all is lost. There's another one. Oh, that's a... Oh, yeah, that's one of those. There's a rotifer. Might have squished the rotifer. There's another rotifer. That one's fine. But there is like a particular ciliate that I'm looking for and not finding here. Maybe I should go to the 4X. Yeah, there I squished a rotifer. Okay, we'll go to the 4X. See if I can find some of these elusive critters. Oh, there's a good view of that's the one we were looking at earlier. There you can see the macronucleus actually really clear now, because I think I definitely did squish the cover glass and the slide closer together. And now this one is more contained here. Oh, let's do phase contrast. Let's go this way with it. We might be able to see the pull this out. It's not super duper clear, but you can see a darker region inside of it there where the macronucleus is. And that's the kind of thing that phase contrast can really highlight, is like, you know, that macronucleus is going to be like, yeah, there's, see it clear. You will have a very slightly different refractive index than the rest of the organism, and that'll show up in phase contrast. There you go. You can see it kind of snaking inside of there. We'll go to 10x here. Position. And we'll look around 10x phase contrast a little bit, just for change of pace. Hey, Kebab Comment, welcome back. Yeah, the orange, you know, there's a lot of like orange algae and whatnot in this sample, so anytime I'm seeing that, I'm just like, well, it's probably some kind of algae remnants. And you can see the the cilia quite clearly in phase contrast, which is pretty cool. Those would be hard to see in Brightfield. Oh, there's a... right, I forgot I put a Basilaria on here. Those of you that are not regular viewers, Basilaria is a colonial diatom where the individuals stay kind of linked together. It moves like an accordion or something like that. These colonies can get very large, many millimeters long. Okay, let's go back to 10x phase contrast. It's interesting though, yeah, I haven't seen oh, these are so cool. I haven't seen the oh, there's the worm. The worm's okay. I haven't seen the other little ciliates that I was expecting to see. They might have expired while they were on the slide. But I think there weren't that many either, so let's try this. Sorry for the... Here's my other neutral density filter. Yes. Go. Oh, there's one. Yeah. Cool. All right. Yeah, kind of small. Take these off. Whoops. Let's see if I can find it. Okay, excellent. Yeah. So this in, open that up. Oh, where'd you go? Yeah. So this is, I don't know the exact species, but this is a common marine interstitial ciliate. This is a Trachylocercid. There's like Trachylocerca, Trachyloraphis, one other one. There are a few groups of these long, slender ciliates, highly contractile. They all have kind of a little mouth at the front, a little stinging cell mouth. And there are so I have a book of marine interstitial ciliates, and these things take up several pages. There's a, essentially it's kind of the book is sort of in one section, just sort of like a picture book. And so there's drawings of all these different species, and the Trachylocercids, there's just page after page after page of different species. And they're all they're all very subtly different, and you kind of have to rely on you have to read the descriptions really carefully, and I think the size is really important. So very difficult to identify these, but they are neat, and they're kind of like they're just a critter that is very distinctly marine. I think there are some freshwater species, but I mostly see them in marine stuff. And some of them can get like very long. Some of them can get multiple millimeters long. I've found those before. That's pretty wild. Yeah. I don't know if I had any others on here. I'm glad we found that one at least. Oh, this is a spiral cyanobacteria. This is I think this is Arthrospira, I want to say. Not yeah, is it Arthrospira? Yeah, there's two different ones. I had this down for a while. I gotta relook at that. Yeah, these guys are all kind of collecting over here. Nice. Oh, this has been really great. We have dropped essentially 0% frames. We dropped a couple. We dropped like on the 4K stream on YouTube. We dropped about 50 frames, and we dropped about 12 frames on the Twitch stream. That's pretty cool. Well, there's this guy. This guy's not looking so hot. Let's see if there's anything else we want to pay attention to on this slide. Nice ciliate. Let's do a little bit of polarized light. Just to say we did. That over. No. Up. Let's pull this out. We got a worm here and a ciliate. Ooh, that's interesting. Look at that. The kind of the oral apparatus on this ciliate has some real nice birefringence going on. Let's add in a little bit of color. there's a nice fire sigma there. Oh wow, these little guys are pretty birefringent. Whatever they've been eaten. It's up here where they were all like co-located. Yeah. Oh, there's another, that's a different species, actually. I think. Of, our little, Tricholocericid? Yeah, definitely. Ooh, look at this one. This one's so much more, like, slender. Fast too. Okay, I'm gonna turn this way down. Go find that thing. Where is it? There it is. I think that's a different one. I don't know. It's hard to say. Maybe it's not. I think it is, though. I'm pretty sure it is. Let's see. We can go to... Is there like a bright spot in the center here? That looks not correct. Let's see, how's my... That looks decent. It's just kind of like a weird glare. I'm not exactly sure where that's coming from. Shouldn't be there though. Oh, weird. It looks like almost like a light leak or something. This is in position. Is there something on my condenser? Oh well. Well, that's probably something we'll find out another time. A lot of times these things will just sort of... eventually I'll be messing around with it and I'll figure out what I did wrong. And then around... something silly. Well, anyway, I think let's see, how long have we been going? Yeah, we've gone for 2 hours, 2.5 hours, something like that. 2 hours 15 minutes. Yeah, 2 hours 15 minutes. Yeah. So I think we'll call it a night here. And but yeah, we'll be back next week. And as long as I can get my my dual OBS configured again, we'll be doing another dual Twitch stream. So if you are watching on Twitch, I highly encourage you to come over to my YouTube channel, youtube.com/@Diatoms. Diatoms. Give a subscribe there. Again, I stream on both. The YouTube feed is much higher quality. But you know, if you're watching on your phone or something, it probably doesn't make that huge of a difference. Yeah, so we'll be back next week. And let's see, I guess we can see if anybody's live. How do I do this? It used to just be a button on stream together. Okay, raid channel. Well, nobody is currently live that I follow. Yeah. I don't know if anybody anybody has someone that's streaming now that they want to raid. Give you 20 seconds or so to figure that out. I'll go ahead and kill the YouTube stream. So goodbye.